So here we go, like when we were looking at this. So if we're going to graph this, a little bit of a review from what we saw before, it's the less than symbol. So since it's the less than symbol, it's going to be an open circle. And then even if this was this equation, if I just flip the whole thing, it would be a greater than symbol, but we still have the open circle. When we turn around and graph it, each one of those things are actually equivalent. When we graph it, it says that the shaded region needs to be less than 6, and then the opposite one down below, 6 needs to be on the shaded region. Or we're going to wind up shading to the left because we want the shaded region to the left of or less than 6. Conversely, 6 needs to be more than the shaded region. So 6 needs to be to the right of all the shaded stuff. If that makes sense. Now, when we go ahead and take the interval, we've got this graph, and it goes on forever to the left. So we're reading it to the left, and we say it's coming from negative infinity, and it's going all the way to 6. Now, we have open parentheses on both of those because we don't actually reach either of those numbers based off of the statement. A little bit different when we talk about B. When we talk about B, we're going to drop a -4 down here. It's a closed circle. It's a closed circle because we have the equal to part. This represents that we can actually get to that -4. And we have all the values that are greater than -4, or all the values to the right of. The shaded region needs to be to the right of -4. And that's what we would get for a graph. When we're going to read this graph from left to right, we notice that there's nothing here all the way up until we get to 4, but we include 4. Or -4. So we're going to drop -4 as the critical value. It includes -4 because it's a filled in circle, because there's the equal sign. And then it's going to go to the right forever and never. Forever, ever. Yeah, forever, ever. Sorry, Mr. Jackson. Ooh, I am for real. That's a song, by the way. Anyways, so when we look at C, we have x is less than -2, less than or equal to -2. So that's the wrong side of the equal sign, friend. It's a -2. So we're going to drop -2 on there, and we have a filled in circle saying that x is less than or equal to -2. So we're going to turn around and go to the left, meaning the shaded region to the left of -2. When we do that and we read for interval notation, we read from the left to the right, would be negative infinity all the way to the left. It keeps going. So we're going from negative infinity all the way up to -2, and we're stopping there, but we're including -2 because it has the equal sign. So we need the close bracket. One of the situation is when we're solving, there's a little bit, the difference with this is that we need to turn around. If we end up dividing by a negative, we've got to do something. We've got to flip the inequality sign. Without getting into the crazy math as to why that exists, just take it for granted that has to happen. So here, when we're going to solve it, we're -8, we get x is less than or equal to -7, and that's totally cool. And then after we get that, we're going to go out and graph it. So we get -7, closed circle. It's less than that, so we want to go to the left of -7. Again, interval notation, we're going from negative infinity to -7. We're including -7 with a bracket. Okay, now let's take a look at 2. When we go and solve this, we've got to pay attention to the fact that we have this negative out in front of the variable. Okay. When we have that and we multiply or divide by a negative number, this is what that big old box says. Okay, when you multiply or divide by a negative number, you need to make sure to flip the inequality sign. So flip the inequality sign. It's not that the 30 is negative, it's that the 3 that we're dividing by, the thing on the bottom, is the thing that needs to be negative. And if we do that, we need to flip that inequality sign, okay, to make it consistent in a true statement. Now we're going to drop 10. Open circle, we're going to go to the right because it's greater than is to the right. The shaded region needs to be greater than 10, so we go to the right. Also with this, when we talk about interval, we go from the left and see where we start. There's no shaded, not until we get to 10, but it's an open circle, so we use a parenthesis instead of a bracket, and it goes to the right, so it's positive infinity. And we always have a parenthesis on infinity, don't forget that. Okay, again, we have a situation here. We're going to multiply through by -4. Those would cancel. We left this with this stuff on the top. Now on the right, what we have to put, 6 times -4, we get -24. We have to remember to flip this thing, okay? When you multiply or divide by a negative on both sides of the inequality, you have to flip the inequality sign. Kabish? Kabish. Okay, so we're going to add 3. We're going to add 3, and we get 7x less than negative 19. Divide by 7. Divide by 7. We get x is less than negative 19. Notice how the inequality sign had been flipped when we divided by a negative. Then we're going to graph that again. Negative 19. It's shaded is less than negative 19, so we shade to the left. And then we have interval. We start from the left. We get negative infinity all the way to negative 19, and we stop there. But we have an open parenthesis because we actually don't get to negative 19 because there is no equal part on the equation. Let's keep going. We're almost there, my friends. Here we go. We're going to distribute. So we get negative 12x plus 4 plus 6x greater than or equal to 16. Then we turn around and negative 12 plus 6 would be negative 6x plus 4 greater than or equal to 16. We keep going, keep solving. 6x greater than or equal to 10. X is, we have to flip this inequality sign now. So when we divide by negative 6, we need to make sure to flip that inequality because we divided by negative 6. So we end up getting negative 4. That's our inequality. Now we're going to turn around and we are going to graph that. So we get negative 4, fill in the circle, and it's the shaded region to the left of negative 4. So that's what we get. And when we go ahead and write the interval, we go from the left, negative infinity, all the way up to negative 4, and close bracket there because it's a filled-in circle when we get there. Okay. Here we go. Went on 2 pages, but that's okay. Let's go ahead and take a look at 5. So we're going to distribute. So we get negative 6x plus 15 greater than negative 6x plus 9. Go ahead, collect like terms. Variables on one side of the equal sign. Now we have a weird situation. So I'm going to slow down a little bit of explanation here. But we get a statement that says 15 is greater than 9. Is that true? Is the question. X is dropped out. That's okay. We know that happens. So 15 is greater than 9. We know that's a true statement. Yes, that's a true statement. That is accurate. So since that's true, we actually have all real numbers as our solution. And we have the full filled in number line. Also, when we talk about this too, interval notation, if we fill in the full number line, it's going to be all the way to the left, so it's negative infinity. When we move all the way to the right, we're going to end up getting a positive infinity. So that incorporates all of the numbers you could possibly have for it. And then one last one, we're going to skip the very, very last one. So anyways, we're going to turn around, distribute 2. So we get 4x minus 4 less than 4x minus 6. Subtract 4x from both sides to collect the variables on the left-hand side. At least that's the goal. They drop out and we get negative 5 is less than negative 6. And we ask ourselves, we say it out loud if we need to, negative 5 is less than negative 6. Is that true? No, that's not true. No, that's not true. Not true. If it's not true, we say no solution. Okay? Since that was not true, we say no solution. We don't fill in anything in the number line. We just leave it blank because the number line is all the numbers that make a true statement, that represent the solutions. There are no solutions, so we can't fill it in. Interval notation, this one's a little bit tricky when we actually write it in interval notation because we want notation that says we don't have any numbers in it. So I like to use 0, 0 with parentheses to say where we have nothing. Nothing's in there. It's parentheses around 0 on both sides, which means you can't actually get to 0 from either side. So it's no solution. Cool. Hope that helped you. Hope you have a chance to do that. Go ahead and do that little quiz that I put at the end on forms on Teams. So it's brand new on Microsoft Teams assignments. There should be an MS4 there, which will give you a little quiz based off of this in addition to your notes. All right. Take care. Peace.